In ALEX, there's a topic called Solving a Basic Trigonometric Equation Involving Sine and Cosine. And they ask you to find all the solutions to a particular equation. And they want you to write your answer in radians in terms of pi and use the or button as necessary to write your answer in this form. Okay, so I'm gonna kind of explain some of this as we go along. I want to give you a little background information, things that you need to know in order to solve these. I think in a way that involves less memorization. And this is something you're already familiar with. You're already familiar with 45, 45, 90-degree triangles and 30, 60, 90-degree triangles. So if you're already familiar with those, then you're just kind of using that information and the information you know about sine and cosine to solve these. So we're going to use these special triangles to come up with what angles we have, basically. So you need to be familiar with these. So I've also listed this in terms of degrees and radians. So 90 degrees here is pi over 2 radians. 180 degrees is pi radians. 270 degrees is 3 pi over 2. And then all the way around, this value here would be 0 degrees or 360 degrees if you go all the way around. Or this line right here is going to represent 0 radians or 2 pi radians. Okay? So I'm going to talk about this in degrees and then kind of help you to be able to see how to convert it to radians. Okay. So 45, 45, 90-degree triangle. If we make the distance from of the two sides 1, then the hypotenuse would be the square root of 2. So you need to be familiar. This is how I want you to set up when you know it's a 45, 45, 90-degree triangle. Or in this case, what you're going to do is you're going to be able to fill in 2 of these values. And if you recognize you have 1 and a square root of 2, you know the other side is going to be, the other leg is going to be a 1. Or if you have 2 an x and a y values that are both 1s, then you know this hypotenuse is going to be square root of 2 and you have a 45-degree reference angle. Kind of see what I mean as I go on and show you the examples. For 30, 60, 90, the leg opposite the 30-degree angle is going to be our 1. And the leg opposite, then the hypotenuse is always double the short leg. And then the long leg is the short leg times the square root of 3. So you're going to end up with this 1, 2, square root 3. Okay, so opposite of the short leg is 1. Hypotenuse is double that. Long leg is the square root of 3 times the short leg, so it's just the square root of 3. So these are the values we're going to use. The other thing you need to be aware of is sometimes you're going to have angles that are actually on your axis, either your x or y axis here. So when that happens, what you want to do is always think of r as 1. So if r is 1 and I have a point over here, I'm talking about this angle here, my x value here is a -1, and because I'm going out the distance of 1, and my y value would be 0. Okay, and this will kind of make more sense as you see the example I'm doing. Okay, and you should have used some of these in a chapter we did earlier. The other thing you need to kind of be aware of is that if I am looking for an angle, if I know the angle is in quadrant 2, and this is the angle I'm looking for, I want to look at the reference angle. So I make the right triangle come down to the x-axis. This is my reference angle. Okay, so what you're going to be doing is determining the reference angle, one of these things. Okay, and then from there you're going to calculate your angle. So what I want you to realize here is if I want to know what this angle is here, and I know what the reference angle is, either 45, 30, 60 degrees, then what I would do is I would take pi, because all the way around here would be pi, and subtract my reference angle. So if it's in quadrant 2, I'm going to take pi and subtract. I'm going to call it theta prime. So that's my reference angle. If I am trying to find an angle in quadrant 3, my reference triangle or my reference angle, right here, I draw this down or up to the x-axis. Here's my reference angle. So you can see if I know that this is pi, if I add the reference angle, I'm going to get my actual angle. So theta equals pi plus my reference angle. Okay, and I should have put theta here equals. And do that, sorry about that. Okay, so in this one, if it's in quadrant 4, you can see here's my angle theta. My reference angle I get from making that triangle up to the x-axis. And so all the way around here would be 2 pi. So to find theta, I'm going to take 2 pi. And if I subtract this reference angle, I'm going to get the angle theta here. Okay, so this is why on these kind of problems, I always kind of sketch a picture to see what's going on. The other thing I want you to be familiar with is 45 degrees. What is that in terms of radians? And what I want you to realize is, okay, if this is pi over 2, from 0 to 90 is the same as 0 to pi over 2 radians, 45 is half of 90. So what's half of pi over 2? So pi over 2 divided by 2 is pi over 2 times 1/2. That's the same as pi over 4. The more you do these, the more you just get familiar with them and you just know. Okay? But 30 degrees, okay, compared to 60 degrees. Now, hopefully you're recognizing it's either pi over 3 or pi over 6. Okay? So pi is the distance from here all the way around to the 180 degrees. So if I'm taking that distance or this amount and I'm dividing it by 6, is that going to be smaller or bigger than the value when I take the same value and divide it by 3? If you take something and divide it by 3, it's going to have a bigger value than if you take something and divide it by 6. They give you smaller pieces. So this is going to be your pi over 6, and this is going to be pi over 3. And you can always think of an actual pie, apple pie. If I divide it in 6 pieces, those pieces are smaller than if I took the same apple pie and divided it in 3 pieces. Those pieces would be bigger. So that's why I associate pi over 3 with 60. Okay, so this is a lot of background, but you're going to need this. So if you're still kind of like a little shaky what I'm talking about, you can keep watching the examples and then come back and look at this again. It might make more sense. Okay? Now, when you're given this equation right here, the first thing you want to do is solve this equation for sine of theta. So that means you need to get rid of this plus square root of 2 and the times by 2. So what you're going to do is you're going to subtract the square root of 2 from both sides. That's going to give you a negative square root of 2. And then you're going to divide both sides by 2. Now, right here, what we're going to do is normally we're going to take this sine is y over r. So normally I'd say, hey, make y equal to the square root of 2 and r equal to 2. But one of the things I want you to recognize is anytime you have the square root of 2 over 2, this has been rationalized. The denominator has been rationalized. So, and I know that because the square root of 2 and 2 are this, they both have the 2's in them. Okay, if one was the square root of 3 and 2, then it hasn't been rationalized. So one of the things you can do is just simply to unrationalize it, you can do the same thing you did to rationalize it. You multiply by the square root of 2 over the square root of 2 and then simplify. Okay, so this is going to give me a negative 2 over 2 square root of 2. And I can see these 2's will simplify, these 2's on the outside of the square root, and that becomes a negative 1 over square root of 2. And so this gives me, now I'm going to associate this with my y value and this with my r value. You got to remember, sine is y over r. Okay? Now, what you're going to do is going to go ahead and let's think about if y is a negative 1. So where is y a negative 1? And y would be a negative 1 in quadrant 3. Y's are negative in quadrant 3 and quadrant 4. So what you're going to do is you're going to draw a reference angle in quadrant 3 and bring that down. So and then we're going to draw one in quadrant 4 as well. Okay, so basically we're looking for theta in quadrant 4, this angle here, and another angle, theta, in quadrant 3. Okay, so what we need to do first of all is determine these reference angles. So this reference angle right here is going to be, let's see, so we're actually going to use these values. So if y is a -1, that's this value here, r is a square root of 2. And then you need to recognize from those things that we talked about earlier, what is the reference angle? We can do the same thing over here. Now remember, we're going to have 1, 1, square root of 2. And in this case, x would be -1, and over here x would be a +1. Okay, and that's okay because there's no value, it doesn't tell us what x needs to be, but we just know. So this is going to be a 45-degree reference angle, which is pi/4. Okay, so to calculate what this angle is, what the actual angle theta is, we need to take pi and add it to pi/4. Well, we can turn pi into something that has denominator 4, so we can add them together by rewriting it as 4 pi/4 and add them together, and that gives you 5 pi/4. Okay, so that's my first angle. I'm going to write it here. We're going to come back and add all this to it in just a minute. Let's calculate the next one. So if I'm calculating this angle here in quadrant 4, remember, to find theta in quadrant 4, I take 2 pi, because all the way around is 2 pi, and I subtract the reference angle, which is pi/4, reference angle. Okay, so I do the same thing to get a common denominator here. I'm going to multiply this by 4/4. That gives me 8 pi/4 minus pi/4, which is 7 pi/4. Okay, that represents the angle in quadrant 4. Now, that's if we just do one rotation, but this is basically asking us to give all possible answers. So basically what this is saying here, this means k is an element of the integers. So this little symbol z represents integers. Integers are the numbers, -3, -2, -1, 0, 1, 2, 3. So positive and negative, basically whole numbers. Okay, that's what an integer, that's what this symbol represents, integers. And so basically what this k is saying, hey, if k can be any integer. So if k is 0 here, I get this angle here. If k is 1, I get 1 pi. Okay, and that basically what 1 pi represents is a half of a turn, basically. I'm going from here to here. Okay, so 2 pi, this is the one you're actually going to use a lot of the times, is 2 pi is one rotation all the way around. So basically what I'm going to do is we're going to say, hey, any angle, this angle here, or if I went all the way around once and came back to this reference point here, and more, maybe I'm going to go around twice and come back to the same point. If k was 3, then that means I'm starting here, I'm going around 1, 2, 3 times, and then I'm going to add that value here. Okay? So basically, once you get these answers, I'm going to say plus 2 times k times pi, where k is an element of the integers. And so it gives me my answer with one rotation, or with less than one rotation, right? And then any other, extra rotations around. I could rotate around here 5 times. If k was 5, that would represent 5 extra rotations around, plus going to 5 pi/4 after that. Okay? So I'm going to do the same thing with this one. And this is most commonly what you're going to do. I'll give you an example where we're going to have something like this. And this will be an or. Because given this equation, I have all of these answers. Okay? Let's look at another couple examples real quick. I'll go through this one a little bit faster. This is cosine of theta equals a negative square root of 3 over 2. And you can see it's already solved for cosine, so that makes it easier. You've got to remember that cosine is x over r. By the way, r is always positive. Okay? So if there's a negative, it goes with your x or your y value. So we're going to use x as a negative square root of 3, and r is 2. Okay? So first of all, x is negative. What quadrants is x negative in? So x is negative, is to the left of the origin, so it's going to be in quadrant 2 and quadrant 3. We're going to have 2 reference triangles. So I'm going to draw one here. Oops, I'll do this one, and one in quadrant 3. Okay, so we want to find this angle theta here and this angle theta here. So we want to find the reference angles. So I'm going to draw my little reference triangle. Okay, now I'm going to label my values. X is going to be a negative square root of 3, and r is 2. Okay, so then you need to recognize, okay, what kind of triangle is this? Well, it's got square root of 3 and 2. It's going to be a 30, 60, 90 degree triangle. The value I'm missing is the 1. So here, y would be 1, and in this one, y would be a negative 1. Okay, so we have our reference angles here. Opposite the 1 is always the 30 degree angle. And remember, how do we represent 30 degrees in radians? It's pi over 6. Okay? So now what we're going to do is we want to find out what theta is. Okay? So in quadrant 2, I'm going to go to pi and subtract the reference angle. So in this case, that's going to be pi minus pi over 6. I can rewrite pi, I can multiply that by 6 over 6, so I get the same denominator. Gives me 6 pi over 6 minus pi over 6, which gives me 5 pi over 6. Okay? So I'm going to write that over here. And now in quadrant 3, remember, I'm going to go all the way to pi, and then I'm going to add my reference angle. So I'm going to rewrite pi as 6 pi over 6 again, plus pi over 6, and that gives me 7 pi over 6. So those are my angles. Now we're going to add the rotations. Plus 2 times, k, they always do k first, times pi, where k is an element of the integers. You want to say that. When you see this, you want to say k is an element of the integers. Okay, we're going to do the same thing here. Plus 2 times k times pi, where k is an element, it's supposed to be a k, sorry, of the integers. And this is an or. And you need both of them in your answer. Okay, so you can see as you're going along here, these will get faster. You get faster at them. Okay, so here's one more. Now this one I'm going to go ahead and solve for cosine of theta again. I'm going to subtract 1 from both sides and get cosine of theta equals 0. So we're going to write this as a fraction, and we're going to put it over 1. So anytime you have 0 or 1 for cosine or sine, you can make it into a fraction over 1. So remember, cosine is x over r. So x is going to be associated with the 0, and r is 1. Okay? Whenever you have something like this, that's a good hint that it's going to be at one of these points here. So x is 0, r is 1. Let's see. If this is, whenever you have something like this with 0 or 1, then that means the y value will be 1. So x is 0, y could be 1 or negative 1. So y could be 1, or it could be a -1. Okay, so we're looking at theta here, or theta to this value. Okay, because if x is 0, then y has to be the same distance as r. Okay, this is 1, and so r is 1, x is 0, y is a -1 kind of thing. This one is r is 1, x is 0, y, oops, yeah, y is 1. Okay, so we have our values here, pi over 2 and 3 pi over 2. But what I want you to see here is these are each pi units away. Okay, so we're saying pi over 2 and 3 pi over 2. What I want you to see here, this is one of the special cases where if I add pi to pi over 2, I get 3 pi over 2. If I add pi to 3 pi over 2, I come back and I get to this reference angle again. So this is a special case where I'm just going to start with the smaller angle pi over 2. I'm going to say plus k times pi. I'm going to get a solution every pi degrees, where k is an element of the integers. And that's your answer. Okay? I want you to think about that again. If k is 0, then I get pi over 2. If k is 1, I get pi over 2 plus pi gives me 3 pi over 2. That gives me this value. If k is 2, right, I get 2 pi plus pi over 2. That gives me all the way around plus back to this point again. Okay, and it's just going to keep giving you these intervals.